So we are moving into section 1.3. 1.3 today is all about algebraic expressions. Algebraic expressions just mean that there's no equal sign to begin with, right? An expression does not have an equal sign in it. So we're going to be writing expressions from words. So we need to talk about some of those important words. I know. So let's talk about addition first. What are some words that mean addition? Add. All right. Add it is. Plus. Some. Oh. How about increased by? All right. So the next two we're going to write down are super, super important. Super important. Because they're special. We have greater than. And we have more than. Those mean to add. But they're special. Because if you recall back to algebra, I call them flip-flops. All right? Because of the word than, you have to write them in reverse order. All right? So, for example, if I was to say W increased by 7. That is in the order you write it. So I have W increased by means to add it, and then 7. That goes in that exact order. However, if I were to say W more than 7, we have to flip them. So 7 has to go first, plus W. All right? So anytime, I'm going to clean that up a little. Sorry about that. Anytime you see the word than, it flips it places, right? All right. So if we talked about addition, we do have to talk about subtraction. Let me get that up here. All right. So some words that mean subtraction. Minus. Subtract. I'll put that up here. Good. Less than. Awesome. Good. Look at you go. All right. We can do fewer than. That's another one you might see. And there's one word you guys haven't included yet. It does start with a D. No. We got that already. No. Yeah, the difference. All right, so a couple of those real quick. If I were to say the difference of K and 4. Again, because there's not the word than in there, you have to write it in that order. So this would be K minus 4, or subtract 4. However, if I were to write it as, let's say, how about K fewer than 4, because of the word than, I actually have to start with 4 and subtract the K. All right? Questions on those? That than is pretty important. It's going to tell you which direction you've got to write it. All right, so if we talked about adding and subtracting, we've got to talk about multiplying. Now, before we talk about the words that mean multiplication, give me some of the symbols that mean multiplication. What else? Yeah, it's when they're next to each other. So if I had two things right next to each other, that also means we're multiplying them, right? Okay. All right, some words that mean multiplication. All right, multiply it is. Times, good, times. Sometimes by is in there. No. Yeah. Yeah. When you say and, it's actually telling you prior to that what you need to do with it. So if you're just saying 4 and 6, that's not telling you what you're doing with them, right? You've got 4 and you got 6. Yeah, are you adding 4 and 6? Are you multiplying 4 and 6? Are you subtracting 4 and 6? You have to have that first. So and doesn't really tell you anything. All right, so let's go back to multiplication. There's one word that you're going to see probably the most often. Product, yes, product. Now, a couple other things that might mean multiplication you might see. What if I said double? Yeah, you can say triple. Those all mean that we are multiplying by a set number, right? All right, so let's talk about division. So let's start with what are some symbols that mean division? Fraction. And that fraction bar can go at an angle or straight across. What else means division? The division sign. There's one more. Oh, yeah. With the two dots right here? Like that? Or do you... Oh, yeah. So it's like a ratio. Yep. I agree. And there's one more that you guys used back in elementary school. The little housey thing. Right? So the reason listen. The reason I include the house, as you call it, is because back in grade school you divided that way, right? Long division. This year you will be using that symbol as well to divide equations, expressions. So, no. All right, so let's talk about some words for division. Divide. Over, yep, over. It's kind of like your fraction bar, right? I think that's more div, then we'll put it there. All right, here's the one you're probably going to see the most, though, is quotient. Oops. And then, I know it, my bad. And then the other one is splits evenly. And I probably could say half. If I say half of, what does that mean I'm doing? Divided by 2, right? All right. So back in algebra, you did expressions, and there was only one thing you had to worry about, right? Well, you're in Algebra 2 now. So let's see if we can't write an expression. It's a little bit more complex. So here's example number 1. Let's say we need to write an algebraic expression for the sum of 5 and the product of 6 and x. Ooh, be careful. There we go. 5 plus 6x. I agree. Because it is addition, technically it works the other way, but when you're writing it from there, you have to write it in that order, right? Okay. So here's one more, kind of the same deal. What if I said the product of 6 and the sum of 5 and x? Yes. All right, so the product is the main thing going on. It's taking the first number and timesing it, and when we multiply, we can put parentheses around it, the sum of 5 and x. So that's 5 plus x. All right, so those seem pretty good. Let's do one last one then, just to make sure we're golden. Let's do the quotient of 3 less than w and 5. Nope, not quite. So quotient means we're going to do what? Quotient means we're going to do what is the main thing? Divide. Nope, not quite. So if we say, listen, so I have quotient of. The first part of this is 3 less than w. There we go. All right, so let me say it one more time, or I've been trying to say it one more time. The quotient is the main thing going on. The first part of your quotient that comes first is 3 less than w, or w minus 3, and 5, which means that's what you're dividing by, is 5. Okay? Slow down and make sure you're reading all parts of it, right? Okay. Example number 2. Let's write it to model a situation, and anytime I use the word model, that means it's more a real-life situation. Okay? So, write an expression to model the situation. And maybe I say, Colin has $500 and makes 25 each day. Now this doesn't have any of those words we just talked about, but they have forms of those words we just talked about. Yes. So in this case, 500 is what we have to start with, plus, and it's 25 each day, so that means that we have 25, I'm going to put D to represent day, right? So you have 2 of those on the worksheet today. Any questions? We're good so far? All right. So let's move on. Next thing I want to talk about is combining like terms, simplifying expressions. So when we simplify expressions, we may have to distribute. We may have to combine like terms. And then we are going to have to write it in mathematical order. So when I say that, there are 2 ways I want you to think about it. First of all, if all of your terms have x's in it, but maybe you have an x, an x squared, an x to the third, how do you know what term comes first? When you're writing it down, what should come first? Your term with the what?
With the variable.
No. If they all have variables. But maybe one has a variable that's squared, one has a variable that's to the third.
With the highest exponent.
There we go. So when you write them and they're all the same variable, your exponents.
And if they're not the same variable, it's the variable that comes first in alphabet.
Yes. So the exponents are in descending order. And if there are more than one variable, it is alphabetical. Alphabetical. All right, so here is example number 3. For example number 3, maybe I have something as simple as, so let's simplify this. Say I have 3x minus 2x squared plus 7x plus 9x squared. So we want to start with our highest exponent first, right? I have this negative 2x squared and 9x squared. How many x squareds do I have? 7x squared. Remember, you're simply adding the coefficients together, right? Then I have 3x and I have 7x. So I have a total of 10x. All right, obviously that's too easy, so let's make it a little harder. A little bit harder. Let's say I have, we'll keep this underneath, no, actually, let's make it example number 4. Simplify. You with me, Parker? Yeah. All right. Let's say I have 4 times a plus b minus 2a plus 6c plus 9b. So the first thing we have to do is get rid of those parentheses, so we have to distribute, right? So 4 times a is 4a. 4 times b is 4b. We're to the end of the parentheses, so we're done distributing. Now, how do we decide what term should I do first? The which one? Alphabetical, yes. So when you have different letters in there, we're going to start with A. I have 4a and I have negative 2a. How much is 4a and negative 2a? 2a. I then have 4b and 9b. Good, plus 13b. And then we have plus 6c. All right, any questions in simplifying? All right, I only have one more thing to talk about. So we're doing really well. I want to talk about evaluating an expression. So what I mean by that is you're going to have an expression and you are going to be plugging values in for that expression. All right, now here's what I have to have from you. First thing I need from you is for you to simplify the expression. I need you to simplify the expression. Simplify first. Second thing, after you've simplified the expression, we are going to plug in values. And when you plug in a value, what do you have to put around it? Yes, you have to make sure you include your parentheses, right? Okay. So this is, I'm going to start off with a really easy one. All right, I'm going to ask you to evaluate. And maybe I'm going to give you something like x times 3 minus x plus 4x squared. All right, and I'm going to tell you that x equals negative 2. The first thing I want you to do is to simplify this, right? So we're going to distribute x times 3 is 3x. X times negative x is negative. Good, negative x squared. To the end of the parentheses, so I'm done distributing. So I have plus 4x squared. I still have to combine like terms together. I have a negative x squared, and I have 4x squared. Good. 3x squared plus 3x. I want to see the simplest form of it before we plug in negative 2. Okay. So now we're going to plug negative 2 in because we've got it simplified. So I have 3. Anywhere there's an x, I'm going to plug in negative 2. And then we're going to follow order of operations. So in order of operations, we do our exponent first, right? So negative 2 squared is going to give us how much? 4. And then we multiply and divide left to right. So 3 times 4 is 12. Plus 3 times negative 2? Negative 6. So what is 12 plus negative 6? 6. All right. Let's do another one. Huh? Personally, you think we can handle it? Let me do one last example, then I'll stop there if you guys think you can handle it. Okay? It is pretty easy. We are still in chapter 1 and we're reviewing, huh? Yes. Yes. Yes, it's all part of chapter 1. I think I'm on 6, right? Or is it 7? 6. All right. So we're going to evaluate. All right, here we go. Let's say I have 2 times, how about C minus D plus 3 times 2C plus 6D minus 9D, where C equals negative 1 and D equals 3. So you can see right now they're starting to get longer, and we are in Algebra 2 now, where if we were to plug our numbers in now, that's a lot of parentheses all going on, right? So we want to simplify it as much as we can before we plug it in. So here we have 2 times C is 2C. 2 times negative D is negative 2D. Here we have 3 times 2C is positive 6C. 3 times 6D is positive 18D, and then minus 9D. Now what do we do? Yes, combine like terms. So I have C's, they give me 8C, and then I have negative 2D, 18D, and negative 9D. What do I get? Good. So this form of the expression is way better than this form of the expression. Do we agree? So now we're going to plug negative 1 in for C. So I have 8 times negative 1 plus 7 times 3. 8 times negative 1 is negative 8. 7 times 3 is 21. So we get 13. All right? It's really important that you simplify the expression for me. Can it be done the other way? Yes. But students make way more mistakes, okay? Eventually.